Imagine the ultimate cosmic near miss. 66 million years ago, a rock the size of Mount Everest grazes our atmosphere, skips off into the void, and misses Earth entirely. Down on the surface, a T-Rex and a Triceratops continue their daily routines, completely unaware of the apocalypse they just dodged. It is a popular sci-fi scenario, but it relies on a massive biological misunderstanding. We often assume that if the asteroid missed, evolution would have simply hit pause, keeping those iconic movie monsters frozen in time right alongside us today. Look at Earth's climate timeline over the last 66 million years. The Cretaceous hothouse gives way to dramatic temperature swings, ice ages, and massive grasslands. To survive, animals adapted. By the present day, classic dinosaurs would be replaced by highly derived, unrecognizable descendants. Curious, so what exactly would those descendants look like today? Paleontologists have spent decades arguing over this exact thought experiment, trying to look past the fossilized bones to imagine a living, breathing, alternate history. The asteroid's absence doesn't preserve the Cretaceous. It triggers 66 million years of divergent, unpredictable biological pressure. In 1982, Dale Russell, a highly respected paleontologist at the Canadian Museum of Nature, decided to try and build a scientifically grounded modern dinosaur. He chose to study a creature called Stenonychosaurus, a member of the Troodontid family. This was a small, agile theropod dinosaur that already possessed grasping fingers and binocular vision. This chart shows the encephalization quotient, measuring brain size relative to body weight. While most dinosaurs flatline, the Troodontid's curve spikes. Russell projected this trend forward 66 million years, calculating a modern capacity of 1,100 cubic centimeters, right in the range of a modern human. Supporting a brain that heavy requires a structural overhaul. Russell argued the creature would need a fully upright posture, lose its heavy tail entirely, and morph claws into hands. The result of that math was the Dinosauroid. It is a completely fabricated, highly intelligent, scaly reptilian biped that looks terrifyingly like us. Russell genuinely argued that the humanoid body plan is the optimal, inevitable vessel for high intelligence, no matter where you start on the evolutionary tree. But why would a world-class dinosaur expert assume that a genius reptile has to grow up to look exactly like a human being? To understand the Dinosauroid, you have to look outside paleontology. Russell was heavily involved in the search for extraterrestrial intelligence, and he regularly corresponded with astronomers like Carl Sagan. In the early 1980s, the search for alien life was heavily focused on finding intelligence that communicated and reasoned in ways humans could understand. That astrobiological framework bled into Russell's biology. If the universe favored humanoids, surely Earth's own alternative timeline would too. Modern paleontologists, including Darren Naish and Gregory S. Paul, rejected this premise almost immediately. They called the Dinosauroid's design suspicious and criticized the logic behind it. Their core complaint was anthropocentrism, that is, the ingrained bias that humans sit at the absolute pinnacle of the evolutionary ladder, and that all life must be striving to become us. We have the body shape we do because of the highly specific history of our primate lineage. There is zero biological evidence that standing upright on two flat feet with no tail is objectively the best way to be smart. If a troodontid actually survived and kept getting smarter, its evolution would be strictly constrained by the anatomy it already had, not pulled magnetically toward a primate shape. Theropod dinosaurs were built like seesaws. To support a heavier brain, a smart theropod wouldn't stand straight up. It would retain its natural horizontal posture and use its long, stiff tail to counterbalance the heavier head. It also wouldn't need human hands to build a civilization. Modern birds solve complex puzzles and manipulate tools using their highly adapted beak-like snouts and feet. A hyper-intelligent dinosaur would do exactly the same thing. As authors like Dougal Dixon explored in books like The New Dinosaurs, surviving species would adapt to modern ecological niches based on the physical geography of their environment, not human intellect. Evolution demands that descendants build upon the skeletons of their ancestors, meaning an intelligent dinosaur remains tethered to the horizontal skeletal architecture of its theropod frame. Decades after Russell's original sculpture, modern artists and speculative biologists like CMM. Koseman and Simon Roy decided to redesign the Dinosauroid, this time completely free of human bias. This is what a scientifically grounded intelligent dinosaur looks like. It is a highly derived, fully feathered creature that wears its theropod heritage proudly while possessing a massive intellect. You can easily imagine these avian descendants forming complex, tool-using hunter-gatherer societies, proving that you don't need 5 fingers and a flat face to build a civilization. While critics dismantled the model's anatomy, the experiment served a purpose beyond biological accuracy. The resulting debate highlighted the human-centric bias inherent in our scientific models, forcing researchers to rethink how intelligence might adapt to entirely different body plans. If that asteroid had missed 66 million years ago, the world wouldn't be a reptilian mirror of humanity. It would be a radically alien, beautifully non-human planet. And we wouldn't be here to see it.